Hello students, in this video we are going to learn about semi-custom design. In our previous video we learned about the introduction part of unit 5, which is design methods. In this video we'll learn about the semi-custom design. So in semi-custom design, what actually is a semi-custom design? Means nothing but we are going to design our integrated circuit. Okay, so the VLSI chips are being fabricated using certain design methods. One of the method is nothing but using a semi-custom design. Here, the physical design of your large scale or large VLSI system is a complicated process and it cannot be solved in a single step. That we have seen in our previous video, that we cannot make or find a single cost function for our VLSI. That's what we broke our domain into three different domains. So the physical design is a complicated process and it cannot be solved just like that in a single step. It is further broken down into several stages. These stages depend on what design style it is following or adapting. So there are two important design styles that we are using to solve the problem. Means I can go for either a full custom design style or semi-custom design style. So what is this semi-custom design style? Semi-custom designs are nothing but it uses a predefined logic cells. Means there will be AND gates, OR gates, multiplexers, and they are nothing but the standard cells. In semi-custom design, I can directly use the predefined logic cells. I'm not going to design an AND gate or an OR gate. Directly I will go and design an half adder. So I need AND gate and OR gate for designing my half adder. So the semi-custom design uses a predefined logic cells known as standard cells. The designer uses pre-tested and the pre-characterized cells. Means they are the predefined logic cells, so the designer can easily use the pre-tested and pre-characterized cell, and it is widely used, and these cells can be placed anywhere on the silicon. Means it is not that I must place my standard cell in one particular location. I can place the standard cells wherever I want on the silicon. So each standard cell is constructed using a full adder. It reduces the time to market. Means I'm having standard cells. I'm not taking time for designing an AND gate. Consider like a brick of a wall. I'm not going to construct a brick, whereas I'm going to construct a wall. So it reduces the time to the market. So that particular type of designing or constructing a wall, just by placing the bricks, just if you place a brick, you will get a wall, and we are not going to design or make a brick. So if we want to make a brick and then we want to construct a wall, it is highly impossible and it will take a large amount of time. Whereas that is a full custom design. Just by placing the bricks, I can construct a wall, and that is reducing the time to construct a wall, and that is nothing but your semi-custom design. So there are classification of semi-custom design, that are standard cell semi-custom design as well as the gate array based semi-custom design. So in standard cell semi-custom design, there will be standard cells. As I said that these standard cells are nothing but the logic gates, flip-flops and latches. So if I want to make particular design, I can directly interconnect the standard cells using the routing area. I will be having a routing area. So using that particular routing area, I can just route or I can interconnect the standard cells whichever I want to make that particular design. So as I said, there will be standard cells. These will be available inside the standard cell library. Our library will be having a few hundreds of cells. Okay, so I can select any cells from that particular library. If that particular cell is not available, then I have to construct the particular cell by using a full custom design that we will learn in the next video. So now we will see that there will be a standard cell library, and the library is consisting of few hundreds of cells. So larger the library, of course, larger will be the cost of that particular IC. And it is otherwise called as cell-based ASIC, that is CBIC, cell-based application specific integrated circuit. So the standard cell area are built of rows of standard cells like a wall built of bricks. Okay, there will be rows of standard cells in the standard cell based custom design, semi-custom design. There will be a rows of standard cells, and the standard cells may be used in combination with larger pre-designed cells, perhaps microcontroller or even microprocessor. Okay, so they are known as mega cells. If that is the case, they are known as mega cells. So standard cells may be used in combination with larger pre-designed cells, so called as mega cells. So the mega cells are also called as mega function, full custom block, system level macros or macros, fixed blocks or functional standard blocks. See that all the mask layers are customized transistors and interconnect. So here we will be masking or customizing all our transistors and interconnect, and we are the mask layers. The custom blocks can be embedded. The manufacturing lead time is about 8 weeks. So for designing that semi-custom based IC, I need a time for about 8 weeks. So the diagram, see the diagram that shows the cell-based design. This is nothing but the standard cell-based semi-custom design. We are having a standard cell area that will be having the rows of standard cells, and there are certain fixed blocks also. That is 2, 3, 4, and 5 are nothing but a single standard cell area together with 4 fixed blocks. The flexible block are nothing but it contains a row of standard cells. The small squares around the edge of the die, you can see that around the edge of the die there are small squares. Okay, there are small squares around the edge of the die, and they are nothing but they are the bonding pads that are connected to the pins of your ASIC, because I want to communicate with the external world, so I am in need of a pad. So they are nothing but the bonding pads. Each standard cell in the library is constructed using a full custom design methods. Okay, so we will be learning that there will be full custom design. Once you complete semi-custom design, we will move on into the full custom design, and it is going to produce the same performance and flexibility as full custom, but it is going to reduce the design time and it reduces the risk, because everything is easily available and we are just taking from the library and we are going to create or frame or produce our particular semi-custom based IC. And the next type of semi-custom design are nothing but the gate array based semi-custom design. The transistors are predefined on the silicon wafer. The predefined pattern of transistors on a gate array. Okay, there will be various gate arrays. See, previously we saw about the standard cell based gate array or semi-custom design. Now we are learning about the second type of semi-custom design, which are gate array based semi-custom design. Here we will be having certain predefined pattern of transistors on a gate arrays, and which is nothing but the base array. The smallest element that is used to make the base array is nothing but the base cell. Only the top few layers of the metal which define the interconnect between the transistors are defined by the designer. Means there will be certain gate array and they will be having a predefined pattern of transistors. Everything will be there and the gate arrays will be there. In previous case, there were standard cells and we can connect the standard cells according to our wish. Whereas here, there will be certain gate array and only the top few layers of metals will be available, and that is going to define the interconnect between the transistors. So as transistors are already available through the gate arrays, or I can call it as a base array, and we will just define the interconnect between the transistors. This is otherwise called as masked gate array. The designer chooses from the gate array library of predefined and precharged logic cells. The logic cells in the gate array library are often called as macro. See, there are types of gate array based ASIC. Once we learn all these things, we will have a clear-cut idea about the gate array based ASIC. So this is channeled gate array and channelless gate array and structured gate array. So what is the array? Is collection of elements. What is gate array? Collection of gates. So there will be a collection of gates, and here we will just give the interconnection interconnection. Okay, that is nothing but the gate array concept. In gate array concept, we have three different classification. So the first is the channeled gate array. Here our gate array is channeled. Gate array is nothing but the collection of gate that are nothing but the transistors. We are going to just give the interconnection to make sure that our particular design is being fabricated. So the gate array is channeled, so only the interconnection is customized. The interconnect, what is going to do, we are going to do for the interconnect is, the interconnect will be using the predefined spaces between the rows of base cell. Base cells are nothing but the gate array. Okay, so the gate array is the basic element of your gate array is nothing but the base cells. So the interconnect we want to give. So what we are going to use, or which space is usually used for interconnectors, there will be some spaces between the rows of base cells, otherwise called as channels. There will be various gate arrays. In between there will be a channel, and that channel is going to act as an interconnection space. So the manufacturing time is just 2 days and 2 weeks. Uses a rows of cells separated by channels used for interconnect. Okay, it is also same as the cell-based interconnect IC, but the space for interconnect between the rows of cells are fixed in height in a channeled gate array, whereas the space between the rows of the cells may be adjusted in the cell-based design. So whereas in standard-based cell also we had the standard cell rows, and there was a place or the space for placing your interconnect, but the space between the rows may be adjusted in a cell-based IC, whereas in this channeled gate array, the space is also fixed, and the predefined transistors of the gate arrays are fixed, and they can just give the interconnection through the place or through the channel that is meant for giving connection. And the other technique, which is other design, is called as channelless gate array. So in channelless gate array, there will not be any channel. So there will be just a sea of gate arrays. Only some few or mask layers are customized as the interconnect here. So the time is between 2 days and 2 weeks, and the core area of your die will be completely filled with an array of base cells. So it will be just having an array of base cells will be there in your IC. The difference is that there is no predefined area which is set for routing. Previously we had a channel, and that channel is going to act for routing, but here we don't have any predefined area for routing. So how the routing will be done? Routing will be done over the top of the gate array devices. On the top there will be a line. So based through that, on top of the gate array devices, we are going to route. When we use an array of area of transistors for routing, we don't make any contact. Suppose I'm using certain area for routing. Those areas will also be having a gate array which are nothing but the transistors, and we don't make any contacts to the devices lying below. We just simply leave the transistors unused. Unstructured gate array, it's a third type of gate array based semi-custom design. So here, which is nothing but an embedded gate array or a structured gate array. Okay, it is going to combine the features of cell-based as well as the masked gate array. We will be combining the features of both the previous thing, that is cell-based as well as the masked gate array. So what is the disadvantage of the masked gate array? It is a fixed gate array base cell. There will be a fixed gate array base cell. So that disadvantage will be overruled using a structured gate array. So the implementation of memory is so bit difficult in masked gate array because there are fixed gate array cells. The implementation of memory will become difficult. Whereas in the embedded gate array, the set aside some of the IC area and we can dedicate it to some specific function. Means I can have an array of base cells. Okay, there will be various gate arrays, and we don't have any channels over that. We will be just having an array of base cells, and also there will be some place that is set aside that is going to do some specific function. It can contain a different base cell that is more suitable for building memory cells. We said that for your masked gate array, we can't implement a memory, but using a structured gate array, as I'm reserving some place for keeping some other different function, I can use that for building certain memory cell. Only the interconnect is customized, and the custom blocks, whatever we want to do, can also be embedded. So the manufacturing time is also the same, between 2 weeks, 2 days and 2 weeks. So this is all about the semi-custom based design. So here we just saw about what are the types of semi-custom, structured as well as gate array. In gate array, we saw about channeled, channelless, and structured gate array. I hope you understood the video. Thank you.